Hey listeners, it's Paul Andriola here. Why not join our community at Small Cap Discoveries, where we offer our members direct access to some of the best microcap investment opportunities available. Our members are getting access to premium microcap financings, research reports, and direct access to management. Sign up today at www.smallcapdiscoveries.com.
Hi, everyone. Welcome to the Small Cap Discoveries conference call. Today on our call, we have the CEO, Eric Eyerman from California Nanotechnologies. California Nanotech trades on the TSX Venture Exchange under the symbol CNO. The company is currently trading at 11 cents with roughly 32 million shares outstanding, or about a $3.5 million market cap. I'd now like to hand it over to Paul Andriola.
Thanks a lot, Trevor. So California Nanotechnologies, this is a little company we've actually been following for a number of years. And what really piqued our interest here recently is you guys just announced your year-end financials, and you had a banner year for you guys, a 39% increase in revenue and a profit for the year. So very anxious to sort of learn more about the business, get updated in terms of where you guys are at. So Eric, we're going to turn it over to you and just let you start your presentation.
All right, thank you. So, what's your screen share? All right. So thanks, Paul. Thanks, Trevor. Thanks for having me. Happy to be here. Excited to tell everybody about California Nanotechnologies, what we do, and where we're headed going into the future. So, just our standard forward-looking statements page. So now I'll tell a little bit about CalNano. So we're a company that's focused on using cutting-edge advanced technologies that allow metallic and ceramic products take on unique and high-performance characteristics. We can make products that can be stronger or lighter or have unique, electrical or heating properties. Just name a few things. Our services are mainly targeted at making next-generation materials for aerospace, military defense, renewable energies, biomedical, and really a wide variety of other industries. For the past few years, we've been focusing on, high-level R&D and prototyping work for some of the leading companies here in North America, along with national labs and university collaborations, which has allowed us to get to a point where, we've become cash flow positive due to the, high gross margins and high value of these parts, this process. And we've now recently found possibly our first commercial product, which gives us some visibility toward significant increase in sales and in cash flow. And the two technologies that we use are first is spark plasma sintering and then cryogenic milling. And so I'll get into a little more detail about those now. So first we have cryogenic milling. So that's a process where you can create nanomaterials and you can create customized alloys using different elemental powder materials. So about the process, basically the powder is submerged into a cryogenic liquid, in this case, mostly liquid nitrogen. And then that gets put into a ball mill, as you can see in the schematic here. These little round circles here are the media, typically stainless steel. And that is a shaft that gets rotated. The mill's rotated at high speed, and the powder and the media interaction is what creates the breakdown of the particles into nanomaterials. And the cryogenics is what kind of enhances that process compared to a standard mill. Here we do have 3 different mills at our facility. We have a 500 gram, a 1 kilogram, and then a pilot scale. Up to about 7 to 10 kilograms per batch. We did in 2018 receive a patent for securing the key techniques needed for safe and cost-effective large-scale cryomilling for commercial applications. And so we're working with customers now to figure out the best path forward for developing that process. And what are the right applications for this technology into the future. So some of the things I'd like to highlight some of the key benefits here of cryomilling. First is particle size reduction. So that's where we're able to take the material that we put into the mill starting powder, and we're able to reduce it down to nano size. And it's typically very difficult with other processes that aren't at cryogenics, because with the cryogenic aspect, you're actually able to make the material much more brittle, and that allows you to get it down to smaller sizes and faster. Second thing is strength improvement. So one of the key things I like to mention is that we took working with an aerospace company, we took a commercially available aluminum aerospace alloy and doubled its strength just through cryomilling. So no additives, no heat treatments, just basic cryogenic milling, and we were able to double its strength. And we've seen similar results with other material systems such as irons, nickel-based materials, and titaniums, which I know are big in the aerospace industry. Third thing is for sensitive materials. So any material that may be sensitive to air, for instance, say like an iron, who if you are processing in air, it will, oxidize. With this process, you're able to keep everything inert, so that, significantly reduces any type of oxygen pickup. And the same thing because of cryogenics, anything that's sensitive to heat, that will make it not as effective if it gets heated up too much, or be dangerous if it gets heated up too much. The fact that we're at liquid nitrogen temperatures, you're able to process these safely and effectively. Final thing is what I mentioned earlier about making specialized alloys. So we're able to take multiple elemental materials and create unique alloys with this process. So they all get what's called mechanically alloyed together, and you make a unique material. And so we've done a lot of that work with national labs and other companies. And with the cryo milling, you're actually able to do it in about a fifth the time of the standard milling process. So now I'll get into our next technology, which is SPS. Spark plasma sintering, also known as SPS. It's a technique where we take powder and we will make it into solid parts. So similar to what you think of as additive manufacturing, but actually we don't get close to melting temperature. So that has some unique benefits for certain materials. The process you kind of see here in the schematic is powder gets loaded into a die or a mold here, and then you apply uniaxial pressure from this upper electrode down to this lower one, and then the unique thing that sets the SPS apart is that you're actually heating it with electrical current. So that current is pulsed down through the material itself or through the mold, and that allows for very fast heating reach and the ability to consolidate materials that you can't traditionally do with different furnaces that either don't have pressure or that are being heated externally. So it's a really unique in that aspect. And then touching on some of the applications that I'll mention later as well. But in the semiconductor industry, there's applications for it. Ultra high temp ceramics for extreme environment things in aerospace and space. Thermoelectrics and electronics. High value automobile parts. Such as for brake rotors and brake pads that need special materials for those for high performance applications. Just name a few things. Then I'll talk about the benefits of SPS, kind of more specifics. So it's extremely versatile, and that's really helped us continue to grow as a company with the variety of kind of R&D work that we can do. You can do low temperature metallic materials up to the highest temperature ceramics, even working on bonding materials, so a diffusion bonding process. That's really not possible with any of the other sintering processes that you can look for. Shorter cycle times. So again, most of these comparing to conventional sintering processes, it'll take hours to days to go from your powder to your part, but with SPS we can do it in a matter of minutes. So that really sets us apart in terms of being able to do fast iterations and develop materials really quickly, test a lot of different compositions that you're looking to do. And then finally, lower sintering temperatures. So we're able to take, be able to sinter these materials at temperatures that are well below the melting point, and even lower than a lot of the conventional sintering processes. And that has a benefit of, if you put any additives in there that may kind of either melt out, or they may have kind of detrimental effects during the process. If you go too high, then it really has, you really have some benefits with that. So now, just like explain how we work with these technologies. The first thing, and our main focus, is the R&D and manufacturing tool services. So we will provide these services for universities, labs, startups, up to large corporations. Our business is flexible, so we can accommodate customers from just making a few samples to start, all the way up to full-scale R&D programs, with kind of the objective to make Cal Nano into a production center for our customer projects. We're always striving to grow with our customers and give them the parts that they need, whether that be as just R&D, or as, like I said, moving forward to grow with them in more of a production form. Second thing is SPS equipment and tooling sales. So we did start off as the technical representative for our Japanese equipment manufacturer, and just recently have become the official North American distributor. So we're looking at that as another revenue stream, and to continue to grow in that manner. We do all the installation and training, servicing for this equipment, and the equipment can range anywhere from $100,000 to multi-million-dollar systems, depending on your application and what you need to get, parts you need to make from the process. And then we're, like I said, on the tooling sales, we do supply custom tooling, typically graphite, for this SPS process to users in North America. So that will be anything from universities to companies, large and small, that have this equipment will come to us for, because of our expertise, to make the right tooling for their right applications to use during SPS. And so that's how we do there. And then finally, we like to say that we're, a vertically integrated materials R&D, kind of a facility. We kind of act as a one-stop shop for our customers. So with the supporting equipment that we have alongside these technologies, we're able to do things that maybe traditionally you'd have to go to maybe 3 or 4 or 5 different companies to go to. But with us, we can all do it in one place, and that's great for a lot of big places that have to go through a lot of red tape to go to different vendors. So we can take their powder, cryo mill it, process it, sinter an SPS, take it, cut out specimens, do analysis, and do testing, kind of all in the same place. And then that way we kind of act almost as an extension of their R&D departments, which is really beneficial for a lot of our customers. So just talk a little bit about the innovation we've done so far at Cal Nano. So the biggest thing we've done, and the most recent, is working with a company to make advanced thermoelectric materials via SPS that have significantly improved performance. And obviously that's big in the green energy and renewable energy sector. We've done work with both nuclear and oil and gas, where we've developed dozens of different new advanced powder systems for next generation materials in those 2 sectors. That comes back to making those custom alloys, where we combine different elemental materials at all different percentages, and we're able to kind of create unique engineered materials for what they were kind of looking for, and that's how we worked with them for that. Finally, we did work with a multinational semiconductor company. Worked with their engineering team to create a complicated component where we developed through SPS, a part where we could make internal features that they were then going to use that to put into their some of their internal devices that they were going to use, and had much higher performance than the off-the-shelf part. So now let me talk about some of the applications. Here you can see some of our customers that we work with. Like I said, labs, companies big and small. So some of the applications that are possible with these technologies, SPS and cryomilling, aerospace and space, for really extreme environment applications. So looking at high temperature alloys for hypersonics, for shielding or engine components in space travel. Defense, we have transparent ceramics that really can be beneficial to replace different applications where you have to have somewhere where you need glass, but you need something that's much stronger. And so SPS is able to take these materials and consolidate them in ways that other processes can't. We also not mentioned here is just biomedical applications for things like titanium and shape memory alloy, which SPS is really impressive at sintering those type of materials. And then automotive. Actually, in Japan, they are currently in production making the high performance brake pads for bullet trains. So they have a specialty composite material that can only be made with SPS. And because of the kind of extreme high heat that you need when you're kind of putting anything into those type of trains, those type of bullet trains, there's a lot that goes into doing that for SPS. So the other things that kind of we're working on are some high performance brake rotors, and then some work with electric vehicles. And some of these things like soft magnets actually, have been said that they could make electric motors 3 to 4 times lighter with the same performance. And SPS is a really kind of one of the best ways to manufacture these type of materials. And so we're working with customers on those type of applications. So this is some more specifics on the project you may have seen in one of our recent press releases. It's for the thermoelectrics customer. So a bit of background. So traditional, industrial processes, waste about 2/3 of their energy on waste heat. So it's a very, can be very inefficient process. With thermoelectric devices, you're actually able to convert a portion of that waste heat back into electrical energy, which obviously makes it a much more efficient process, a greener process. And using SPS, we were able to work with our customer to make an advanced thermoelectric component, thermoelectric material that significantly improved the properties, improved efficiency compared to the traditional methods that are out there now. And then over the last couple of years, we've done some extensive R&D and prototyping, and the first run of production valued at about $460,000. We have gotten some demand projections from the customer that we see as a kind of beginning end of this year into next year. And we've been working with them and some of the people on how to best scale up and get the right equipment in order to meet their needs and the rest of our customer needs. So now I'll talk a little bit about some of the industry trends that are happening right now. So according to the data, the SPS market is expected to grow about 6% year over year, with the largest market being the North American market and also the fastest growing. So we expect that because of us being experts in this area and a first mover, we expect that our year-over-year growth rate should be even faster than what the average kind of global market is seeing. So I'd like to talk about kind of some of the unique things about Cal Nano and the investment opportunity here. So we're the only company in North America that offers, spark plasma sintering and cryogenic milling with our level of expertise and experience, and with the network that we have to kind of grow these technologies. Our customer base continues to grow. We've worked with big Fortune 500 companies, prestigious national labs, universities, and like I said, that continues to expand as these technologies continue to get more into the mainstream of material science world. We're still sitting at a low market cap stock price, which provides some large opportunity for appreciation moving forward. Some mentioned about the kind of the addressable market of it. It's hard to say exactly what that is, but with the different areas and different industries that you can kind of touch with these SPS products, I think that the potential is definitely in the billions. Even just getting a small portion of all these different industries and even some niche things, it would still be really significant, because all of these markets individually are multi-billion-dollar markets. And then finally, some that I mentioned earlier, we are a vertically integrated company for materials R&D, where it would take multiple firms to carry out some of the things that we do on our own in-house. And I think that's put us in a very strong position when it comes to doing the R&D work that we've done so far, and I think it will continue with that, as along with allowing us to be able to transition that into more of a production manufacturing process. So just taking a look back on our steady growth over the past 7 years or so. So I took over as CEO in the 2017-2018 timeframe. And we've been able to continue to grow, like I said, grow revenue, grow our customer base. We saw a slight dip back in during COVID, but we're able to stay strong with that. And then a quick bounce back for fiscal year 2022, and continue to move that into the future. Finally, just some talk about our overview of our financial information. So as mentioned, we are traded on the TSX Venture Exchange under CNO, OTC markets under CANOF. Outstanding shares of about 31.8 million. This share price is now outdated, as it's like Trevor said, it was at about 11 cents at the moment. Looking at as you see from revenue, more detailed on the numbers, we increased by over 40% from fiscal year 2021. EBITDA and net income, it did increase pretty significantly, as we did become first year being profitable, and we're looking to push that into the future and continue that trend. So that's all I have. Thank you.
Perfect. No, thank you so much, Eric. Let's jump right into some questions here. And you touched a little bit on the sort of what you expect the total addressable market to be, but where do you think are so what areas of your market do you expect to be the faster growers, or the ones that might be more visible to us? If we see that sector growing, we'd expect that you guys would be able to tag along.
I would say aerospace is a big one. Aerospace and just space kind of technologies in general, maybe more specifically in that area, like anything that's going to space, because that is very extreme environments, and with SPS you're able to kind of consolidate these materials that are needed for those type of environments. And we have some projects that are just starting off in the works, that are kind of aimed toward that. And so that would be probably a market that I would say would to look at as something that would kind of affect us. Along with that would be the green energy sector, especially in battery technology. Like I said, our big product right now, big thing we're focusing on is the thermoelectrics. And so as that industry grows, there's going to be more demand for making the next best thing. And again, SPS is very well suited for being able to consolidate those type of materials for enhanced properties.
Mm-hmm. And for you guys to grow from here, do you need significant CapEx? Like what do you need to do to be able to, let's assume, the market does really take off. How do you handle any potential growth from here?
Yes, yeah. So we would need some CapEx specifically for getting additional equipment in order to support our customer needs. We still have a good percentage availability on the current equipment that we have, so we can grow with what we have currently. Just getting some additional staff to support that. For example, when we were doing the thermoelectrics, kind of first run of production, we're running multiple shifts to support that, and that was just for one month or so. So as customer demand increases, we could shift to that model as needed, and that would increase revenue. But yeah, in terms of machines, we would need to get additional equipment in order to support things as they really expand at significant levels, and those are potentially multi-million-dollar machines.
And right now, it's sort of based with what you have in place. What kind of revenue could you do from your existing facilities?
Probably about with the existing things, probably about double what we're currently doing. Would be something
Gotcha.
That, as demand increases, we could expand to that.
Yeah, gotcha.
Really.
Yeah, and give us a sense what the competition, sort of what the competitive landscape looks like right now. Understandably, this is still pretty early in this industry, but maybe even your sort of non-direct competitors, what does that look like? Are they traditionally very big companies? Is it fragmented? Is it small? What does it look like?
Sure. So yeah, kind of like you said, it's limited competition for us. We do have some kind of indirect competitors with companies that are manufacturers of the equipment, who offer kind of the same kind of toll services, but their goal is really just to use that service as a means to sell machines. So they're not looking to push past in the ways that we are, where we can support customers for long-term and for production and manufacturing. They're just looking to do a few samples and send it off, and then get a machine sold. And there are also a few maybe government labs that kind of do something similar, but again, they're not in the same kind of realm, because they're government labs, and they don't have they're not looking at the same kind of ability to expand and use it as a manufacturing facility. There are a few, again, not in North America, but there are a few other places in Europe and Japan that have a similar model to us. But in terms of the North America, yeah, it's very limited in terms of any companies that we would have direct competition at as of now, and the barrier to entry is pretty high, because you need to be able to get these multi-million-dollar pieces of equipment in, and then find the experts to be able to run them, and be able to then support that with a network of customers which we've developed over the years. And like I said, the fact that we are kind of have that vertical integration thing going on the material side allows us to support customers in a way. If you just got into SPS and you just got the equipment, that would be only one small portion of what we can actually offer.
Understood. So, I mean, the sense I'm getting here is that this is highly specialized, highly customized products that you're doing for pretty unique circumstances. Do you see a time where you guys are producing sort of products almost, to put on the shelf that people just come and buy? Do you understand what I'm getting at? Do you see you moving more away from services to product manufacture, or is it likely to stay more on the service side?
I would say in the short term, it's probably more on the services side as we grow, and we're producing kind of the raw material or the stock for our customers to make into put in their devices or put in their products.
Mm-hmm.
But looking more long term, there are developments, and we've been working on and along with our colleagues on creating 3D shaped complex parts.
Mm-hmm.
And so something like that to be able to manufacture then could be a part where we would take that and put it right onto a shelf for these companies to be able to purchase.
Now, you showed a list of companies that you currently products and services for, very big customers. Do you have customer concentration? Give us a sense of how much your biggest customer sort of drives revenue for you.
Yeah. So as of late, our biggest customer was that thermoelectrics company. That was the one that's kind of drove a pretty significant percentage. Probably I want to say maybe 20 to 30% of the revenue of recent revenue was from that customer. And then from there, it's spread out fairly evenly between a company like Boeing, and then some other companies that same kind of level, and then the national labs. But we've seen other years, over the past couple of years, where we have big contracts from a customer. We've had a big contract from, for example, like a big U.S. national lab one year, and the next year it was stuff with Boeing, and so it's ebbed and flowed a little bit. But I think the fact that we're continuing to grow our customer base in general allows us to be able to kind of work with that. For example, when Boeing was really big, and it was doing a lot with us pre Max issue and pre-COVID. And so that took a big hiatus for a long time, where we just it was very sparse, but we were able to kind of supplant that with work from additional customers. And now Boeing's going to be coming back. And so then hopefully that's the idea, is just to continue to grow on that, build on those type of things.
How do you sort of market your services? How does somebody, how does a big customer find out about you guys?
So a lot of it has been through word of mouth referrals. So that's because of the industry, because it is very niche right now. People who are looking for, what we, looking for this kind of service will find us. Or they have colleagues who have worked with us, and they find them. We have done some pretty good amount of SEO work for the website. So again, when you're you're Googling, this type of service, this type of powder production, we're, one of the few people that come up. And so that's driven some good sales. We've done conferences. So we've done, advanced materials science conferences over the years that have, again, it's helped with gain some traction, get networking out, and that's kind of helped the referrals as well. So that's kind of as of right now, that's the way that we've been getting the word out for our business.
For those that are listening today, I know we've got a smaller than usual group of guys, but if you do have any questions, guys, please let me know, and I'll make sure I ask Eric the question. Let's talk a little bit more about the stock. About 32 million shares outstanding. What's the insider position look like?
So the highest percentage is Omnilite. Mm-hmm. So Omnilite owns about 19% or so. Mm-hmm. Other than that, it's spread out pretty evenly. Insiders again have maybe less than 10%. So.
Mm-hmm. Okay. Gotcha. And so your cash position right now, what does your cash need sort of look like in the next 12 to 18 months?
So, we're actually probably we are in the best position we've been in over the past, 5 years, mm-hmm. Since I've been in this position. We've run on a really tight budget over that time. And, with this first round of, with the profitability and the first round of this production work with this thermoelectric customer, we've put ourselves in a good cash position. And I see that that's still gonna, with our continued work, we're gonna be able to sustain over that time, without any issues.
And in the event that sort of things go well and you need to, you need to spend some money to grow, do you anticipate going to the market to raise money, or do you think you've got what you need for the time being?
Yeah, it depends on the exact extent and how fast that situation happens. But yeah, we would anticipate going to the market for a raise. Be looking toward that, as we move into the future here, because for more equipment and that kind of stuff, we'll definitely need that.
Sure, gotcha. And then, I mean, you're still a relatively small company. This is a niche business right now. Lots of sort of changing things that can affect your business. But what do you see as your biggest challenge right now?
I would say that continuing to get our story out there, continuing to get people that are familiar with what we do and the benefits of this technology of SPS, of cryomilling, and see that it has so many different applications. That's probably the biggest thing. I'm starting to look into that in some more, kind of ways of getting out, probably looking into some podcasts, like just all that different possibilities there, to get people to, in the general material science community, to know that this technology, exists and that it has all these benefits, and this is how we can, kind of support them and do that kind of stuff. So.
And then sort of outside your company, as investors, what sort of things should we be watching for that would give us a good idea that the industry or your company specifically is kind of, growing? More emphasis on aerospace, more, airplane sales, more of what should we be watching for?
Yeah, so outside the company, I would say that, yeah, just looking at like kind of what you mentioned before, industries like thermoelectrics, like battery the next generation, solid state battery technology. Obviously electric vehicles are big, and those are going to continue to grow. So those are ones to look out for, as things kind of progress, that would kind of translate to us. And then yeah, like you mentioned, the aerospace. I wouldn't say exactly in direct planes, but maybe if you see things start moving on kind of the more advanced technologies there, so like hypersonic jets, additional advancements in spacecraft, that's the stuff where we can be, our technology can be a big benefit, and where, the more that there's invested in that, the more that it's going to translate to us needing to produce these type of materials.
And you had a bit of a watershed moment with this new customer that you just mentioned, but what other catalysts should we be watching out for? Do you expect sort of similar projects to this, or do you, what other things could happen that could trigger more attention to your business?
Yeah, there's definitely a few other programs in the works that, I'm not currently, able to say too much about, but some work with a big, potential oil and gas company, another one with a startup aerospace company that has some unique things that we're going to be developing with them. And both those industries have, there's a lot of money there, and there's a lot to kind of look forward to in terms of advanced materials and research and then moving into possible, manufacturing for these companies.
Fantastic. This is good, Eric. Listen, we're near the end here. What we always like to do is give you an opportunity to just give a key message or a key takeaway. What sort of key thing do you want to make sure everybody walks away with today about your business?
Sure. Well, I would just like to thank you guys again. Thank everybody for coming. I'd just like to say that these technologies, specifically SPS, they have a lot of potential applications, and we're really just scratching the surface about, what's possible. I just encourage everyone to keep, following our story, how we progress, and, maybe even doing some, their own research into these technologies just to really understand, how specialized and how unique it can be, and the possible things that it can do. And, just say that these technologies, they're just getting started, and so is CalNano.
Fantastic. Okay, so we've been speaking with CEO Eric Eyerman, California Nanotechnologies. Again, the symbol CNO on the Venture Exchange. Great little unique business. Thanks for joining us today, Eric, and we look forward to catching up with you guys in the near future.
Yes, definitely. Thank you.